Alright, let's take a look at these absolute value equations and inequalities, solving them using the graphing calculator. It's lesson 1.7. On this problem, we're going to simply input both equations into our graphing calculator. There's only one equation here, but we're going to split it up into two equations. So everything on the left side we're going to place in y1, so it'll just be the absolute value function on the calculator, and you just simply put inside of the parentheses the entire quantity of that absolute value expression, which is 2 minus a half of an x. And then into the y2 portion we're going to put everything on the right hand side, so it looks like this. And we're simply going to graph it up, and we're going to look at the points of intersection. So let's go ahead and do that. Turn on your calculator and recall that the absolute value is right here in the math section. So you're going to use your right arrow key and go over and select the first option, which is absolute value, and just put in the quantity there inside the parentheses. So we have 2 minus 1/2 x, and close the parentheses. We could graph that to see what it looks like. You can see that the absolute value, everything inside of the brackets there, if it turns out to be negative, then the absolute value function will make it positive. So it goes all the way down. You can see it going all the way down until it gets to 0, and then it starts becoming positive and gets above the x-axis. Okay, and then in the second equation we're going to do what? Put in the value 2, and then that draws a horizontal line. You can see it has 2 intersection spots. Both of them are in the first quadrant. So it asks us to sketch this graph. So we'll sketch a crude graph of this. Try that again. There we go. So we have y equals 2, and then the second graph comes down here, touches the x-axis, and then goes off in that direction. So we're interested in these 2 points of intersection, one here and one here. We'll identify those and then move on to the next problem. So if you recall, the technique for doing that is to hit second calculate, and we're looking for the number 5, the intersection point, and they're asking you to identify the first curve. Well, I'm just going to move over here and make sure that I'm to the left of my first answer, and it looks like it happens at 0, 2. At 0, 2, you can see right here that x equals 0 and y equals 2. So let's go ahead and jot down that first solution so we don't forget it. Whoops, don't want a highlighter. 0, 2. 0, 2 right there. And let's go ahead and take a look at, see if we can find that second solution. Same step, second, calculate, and go down to number 5. And since there are 2 solutions and I don't want the same answer, I'm just going to use my right arrow key, and I'm going to move over close to the solution. And that's pretty close. You can see that your cursor on the calculator screen moves over there. And it's asking me to guess on the second curve. Hit the third enter, and it intersects when x is 8 and y is 2. So our last intersection is at 8, 2. That's right here. So the answer they're looking for is simply when x equals 0 and x equals 8. We're just concerned with the x coordinate. Okay, let's take a look at one of these other 2 problems. Let's take a look at problem number 4. Okay, so in problem 4, same setup, but the only difference on this one, notice that we have an inequality right here. So when I see the inequality, I'm going to read it like this. Oops, let's get out of that highlighter. It's saying that the absolute value of some value has to be greater than 4. So what we're graphing has to be above the line 4. Okay, so let's put these into the calculator, and we'll keep that in mind when we're graphing the solution, that we're looking for something above that. So turn the calculator back on, clear out what we just did. Actually, we can just change this part. 2x plus 3, and delete all this other stuff out. And this time we're going to be graphing y equals 4. And you can see the solution is over here. And we need everything that's above this line y equals 4. So let me see if I can screen capture this for us. Maybe we can draw on the calculator screen here. Okay. There we go. Oops. Okay. So let's move the calculator over here. And so we're looking for everything that's above this line y equals 4. Let me trace over that. So everything above there is going to be on the line. It's going to be this section right here, and it also has another leg over here. So everything that's in the purple is part of the solution. So let's go ahead and trace this onto our graph. We have that line y equals 4, and the absolute value is what forms the V, and it looks like it touches somewhere right here. Goes down, returns back up. So let's identify those 2 points. There we go. We should have this still on a calculator. Once again, we're going to do second and calculate. Go down to number 5, and we'll identify our first point. And you can see that first point over in quadrant 1 is at 0.5 and 4. So let's identify that. We'll call that a half, because that's what it is. So x equals a half. That's that one. And the other one, let's identify that one by using red. We're going to look for that intersection. So go back to your calculator, and we'll do the same thing. Second, calculate. Number 5 for intersection. And recall that we need to get close to the answer, otherwise it will return the same thing we just found. And that answer is a negative 3.5 and 4. So we have a negative 3.5. There we go. And let's shade, as we did on the calculator. We're looking for this section here, right? Now, on this problem, is this one an or an and problem? Is the solution an or an and? That's what we need to find out. Well, look at what we shaded in the highlighter green right here. These two things are going off in different directions, aren't they? So if they're going off in different directions, it's an or statement. So x has to be less than a negative 3.5, or x has to be greater than 1/2. And of course, you also might recall that, whoops, we had a rule that said If the absolute value is greater than, then we use an OR statement. Okay, let's take a look at number 3. Hopefully this video doesn't get too long. Alright. Alright, number 3, we're going to do exactly the same thing. We're going to place into y1 the absolute value, and in y2 we're going to place 9. We're going to graph it up and see what our solution is, but before we do that, we're going to notice that the quantity in y1, which is the absolute value of x plus 8, has to be less than 9. So we're going to be shading everything that's less than the number 9 on our graph. So let's go ahead and put that in the calculator, and let's see if we can come up with a solution here. So the absolute value of x plus 8, just delete that stuff out and type in x plus 8, and on the second line we're going to put 9, and we'll graph it up, and we don't see the entire solution, do we? So we're going to have to zoom out a little bit, but what we do see so far is that, let me take a screenshot of this. Place it somewhere in here. Oh, it's not where we want it. Slide that up here, hopefully. Come on. Huh. What in the world? Let's try that again. Huh. Oh well. I guess we can see that down there. Anyway, we can't see that so well, so we're going to zoom out a little bit. But we could go ahead and start drawing our line 9. So at 9 we have a horizontal line right there. And we know that we do have a crossing right up here. And this thing comes down, touches way over here. And then somewhere over here, which we can't see yet, we have an intersection. So we'll zoom the calculator out so we can get a better handle on that. But let's go ahead and find, before we adjust our calculator, let's go ahead and find that first solution. So in this menu, we can go ahead and hit second calculate, and number 5. Hit enter 3 times. And the intersection is at where x equals 1 and y equals 9. So we have 1, 9. That's right there. Pull the calculator back up, and we need to adjust our window. We can either zoom out, we can do a zoom fit, or another way to do it is to widen out our x window. It stops at -10. Looks like we need it to be maybe a -15. Let's say that. See if that gives us a better picture. Okay, -15. So still doesn't quite get it, does it? So let's just try a zoom fit. You hit the zoom menu key up on the top and go down to 0, which is zoom fit, and hit enter, and still not seeing it. So let's change our window here. -25. There we go. Clearly we can see it now. So remember, we're looking for this intersection right here. So once again, we're going to go to second calculate, choose number 5 for intersect, and let's get in the neighborhood of the answer before we hit enter. And the third enter tells us that it intersects at -17. And y equals 9, so let's do that. That's at actually -17, 9. And let's go back to the original problem. The original problem has the solution being everything less than 9. Since this red horizontal line, which I will highlight, the answer has to be less than, so it's that V shape underneath the line, which we will highlight in this light blue. So those two solutions are coming together. They're being conjoined. So this is a conjunction, or it's an AND statement. So let's see if we can write that up. So AND statements, recall, look like this, where X is in the middle, and you have your inequalities pointing both to the left, and you put your smaller number on the left, which is the negative 17, and your larger number on the right, which is positive 1. These are the X values that we got when we calculated the solution, and we simply put them in that inequality, and that, my friends, is the answer. Okay, hope this makes a lot of sense to you now, and we'll stop there.